All right, so this is question number 7. It's a fairly lengthy question. A says the matrix 1, 2, 1, 3 maps P, which is 1, 2, to P, sorry, maps Q, which is 1, 2, to Q prime, which is 5, 7. This is find the 2 by 2 matrix that maps Q prime back to Q. All right, well, everybody should know by now that if a transformation, sorry, if a matrix takes you from object to image, the inverse of that matrix will take you back from what? From image back to object. So if a 2 by 2 matrix takes you from what? Object to image, the inverse of that 2 by 2 matrix will take the image back to the object. So what we need to do is to find the inverse of this matrix. 1, 2, 1, 3. We need to find the inverse. Well, first of all, the inverse is equal to 1 over the determinant times the adjoint. The adjoint matrix. All right, first of all, the determinant of this, which is 1, 1, 2, 3. The determinant would be 1 times 3, which is 3, minus 2 times 1, which is 2. So the determinant is 1. So the inverse of 1, 2, 2, 3, the inverse would be 1 over the determinant, which is 1, times the adjoint. For the adjoint, you're going to switch around the 1 and the 3. So the 3 comes up here, the 1 goes down here. The 2 and the 1 stay where they are, but their signs change. So minus 2, minus 1. All right, so the inverse matrix, so therefore, this matrix, which is what? 3, minus 2, minus 1, 1. This matrix will take Q prime, which is 5, 7, back to Q, which is 1, 2. So I'll say it again. If a 2 by 2 matrix takes a coordinate, takes a point from object to image, the inverse of that 2 by 2 matrix will take the image back to the object. All right, now let's have a look at B. B, we're told that the vertices of triangle DEF are 5, 12, D, which is 5, 12, E, which is 2, 7, and F, which is a 4. It says I, triangle DEF undergoes an enlargement with center O and scale factor K. Its image in D prime, E prime, F prime, where its image is D prime, E prime, F prime, where D, which is 5, 12, becomes D prime, which is 7.5, 18. A, we're asked to determine the value of K. Here's what we know. Now K, 0, 0, K. This matrix is the 2 by 2 matrix that represents an enlargement, center, the origin, and scale factor K. Now, when this was applied to D, which is 5, 12, it became D prime, which is 7.5, 18. So next we're asked to find what the value of K. It's not difficult to do. I'm going to multiply the two matrices. K times 5 is what? 5K plus 0 times 12 is 0. 0 times 5 is 0 plus K times 12 is 12K. And this is equal to 7.518. And so it is either, and so 5K, and we have 12K at the bottom, and this is equal to 7.518. All right. We need to be conservative with it because we might need some more space. We're doing both sides here, both things here. All right, what else? Let's go over here. So we're at A. So it means that 5K, because if two matrices are equal, corresponding elements are equal, is equal to 7.5. And 12K is equal to 18. Now, any one of these two equations could be used to find K. If I divide both sides by 5, I would get K is equal to 1.5. Over here, if I divide both sides by 12, I would also get K is equal to 1.5. So A is asking us to find the value of K, and the value of K is 1.5. B is asking us to write down the coordinates of, and they just say what? Write down the coordinates of E prime and F prime. So B, now when we apply, we're going to apply the matrix, which is what? 1.50, 0, 1.5. We're applying it to E, which is E is 2, 7, and F is 8, 4. So this is 2, 7, 8, 4. This is E, and this is F. And this is going to become E prime and F prime. If we want, we can work it out. But essentially what's going to happen, it's going to multiply both the numerator and the denominator by 1.5. If you multiply 2 by 1.5, you're going to get 3 here. If you multiply 7 by 1.5, you're going to get 10.5 here. If you multiply 8 by 1.5, you're going to get 12. And if you multiply 4 by 1.5, you're going to get 6. So E prime would be the point 3, 10.5, and F prime would be the point 12, 6. Please note the examiner just says write down. So the examiner is expecting that you should know if K is 1.5, all you have to do is multiply each coordinate by 1.5. He's expecting you to know that, which is why he just says write down. All right, there's nothing more to this side. Let's turn the page. All right, II. So II, it says B prime, E prime, F prime undergoes a clockwise rotation of 90 degrees about the origin. We're asked to determine the 2 by 2 matrix that represents a clockwise rotation of 90 degrees. Now, this is something that I didn't tell you before. Now, but you see, whenever you're asked to determine a 2 by 2 matrix that represents a particular transformation, what you need to do is apply the transformation to these 2 points. The 2 points are 1, 0, and 0, 1. Apply the 2 by 2 matrix to these 2 points, and whatever you get, that would be the 2 by 2 matrix. Sorry, apply the transformation to these 2 points, and what you get from applying the transformation to these 2 points would be the 2 by 2 matrix that represents that particular transformation. I'll show it to you in action. First of all, I'm rotating the point 1, 0, 90 degrees in a clockwise direction. This is a clockwise direction, and this angle here is 90 degrees. So this point, which is 1, 0, is going to become what? The point which is what? 0, minus 1. And so we have what? 1, 0, and we have 0, 1, and we're applying this to this is R O minus 90. It's a clockwise rotation of 90 degrees about the origin. When we applied the transformation to 1, 0, it became 0, minus 1. Now, let us see what happens when we apply the same transformation to the point 0, 1. If I rotate this point 90 degrees in an anti-clockwise direction, that's the direction. This angle here is 90 degrees. So the point 0, 1 is going to become the point 1, 0. All right, so this matrix is the result. This resulting matrix is actually RO minus 90 degrees. And so RO minus 90 degrees, which is a clockwise rotation of 90 degrees out about the origin. The 2 by 2 matrix that represents that transformation is 0, 1, minus 1, 0. So one more time, this is what I said. If you wish to determine the 2 by 2 matrix that represents a particular transformation, apply the transformation to these 2 points. The points 1, 0 first, and then what? 0, 1. Whatever those points become, when you what? Arrange that as a 2 by 2 matrix, that is the answer you are looking for. Let's move on. Next, we're asked to what? Determine the coordinates D double prime, E double prime, F double prime, the image of D prime, E prime, F prime under this rotation. So I'm going to apply the number of columns in the first must be equal to the number of rows in the second. So I'm going to apply this transformation, which is 0, 1, minus 1, 0, to these points. D prime, which is 7.5, was it 7.518? I don't see my D prime. Yeah, 7.518. E prime, which is 3, 10.5. And F prime, which is 12, 6. When we apply it to this, first of all, we need to know, well, first of all, if we wanted to, we could just multiply and get the answer. That's the first thing. The number of columns in the first is equal to the number of rows in the second. We could just multiply and get the answer. Or we could use our knowledge to say that if this transformation is applied to a point, it's going to interchange the point and the sign of the new y coordinate is going to change. So this is going to become the point 18 minus 7.5. This is going to become 10.5 minus 3. And this is going to become the point 6 minus 12. What happened? I interchanged the points and the sign of the new y coordinate changes. This is what occurs when you rotate a point 90 degrees in a clockwise direction. So D double prime would be 18 minus 7.5. E double prime would be 10.5, comma, minus 3, and f double prime would be 6 minus 12. All right. All right, and now lastly, we're asked to determine the 2 by 2 matrix that maps triangle DEF onto D double prime, E double prime, F double prime. All right, now remember to get from DEF to D double prime, E double prime, F double prime, we did 2 transformations. All right, the first one was an enlargement, I think. So the first one we did was an enlargement, which is 1.5001.5. That's the enlargement, and this is the first. And the second one was a anti-clockwise clockwise rotation, 0, 1, minus 1, 0. This is the second. Now, if you want to determine one transformation that represents the combined effect of these 2 transformations, you must multiply them, but you must put the what? The first one last and the last one first. So the combined transformation is the second one first, 0, 1, minus 1, 0, multiplied by the first, 1.5, 0, 0, 1.5. So all we have to do is multiply these and we get the answer. This is 0, 0, that's 0 for the top. This is 0, 1.5. This is minus 1.5, minus 1.50. And this is 0 plus 0. And so our final answer is 0 minus 1.5, 1.5, and then 0. All right. Now, this single transformation could have replaced those 2 transformations, which is the enlargement followed by the clockwise rotation, the enlargement of a scale factor 1.5 and sent to the origin, followed by a clockwise rotation of 90 degrees about the origin, could be replaced by the combined transformation 0, 1.5 minus 1.5, 0. All right, and this is the end of the question.